Here we're looking at exercise 6b, question 16. So it's one of the rates questions from the Algebra 2 chapter. We're going to go ahead through this question and try to draw a diagram as we do. So the first bit of information that we have is that a freighter is sailing due north at 12 kilometers an hour. Now, I might not have any idea about what a freighter is, but given that it's sailing, I know it's going to be some sort of boat or ship. So I'm going to draw it down here, just as a little ship. And we're told that's going at 12 kilometers an hour. Now, we're also then told, I want to pick a different color highlighter for this. Okay, so we're also then told that it sights a cruiser straight ahead at an unknown distance. Okay, so again, I might not know what a cruiser is, but it's not so important. I'm just going to draw a cruiser like that. So some sort of boat again, and we're told we don't know what this distance is, so we're going to call it x. And we're also told that the cruiser is speeding due east at an unknown speed. So the cruiser's going that way, and it's traveling at a speed of s kilometers an hour, whatever that s might be. We're then told that after, we're then told that after 15 minutes, they are going to be 10 kilometers apart. All right, so if we look at it, after 15 minutes, they should be something like, so this black one would have moved up. And this blue one would have moved across to here. And this distance in here is going to be 10. Now, one of the tricky parts of this question is to immediately convert this into the correct unit. Because we're given kilometers an hour, it makes most sense to convert that 15 minutes and make that into, 0.25 hours. Okay, so just a quarter of an hour. So, that makes life a little bit easier for us, because we know that in a quarter of an hour, this ship here would have sailed 3 kilometers upwards. How do we know that? Well, if it's going at 12 kilometers an hour for a quarter of an hour, that's 3 kilometers. So whereas before we had x here, so x on the left-hand side, we're now going to have x minus 3, okay, because this freighter has gone up 3 kilometers. We're also told that this cruiser, the blue boat, has gone to the east or to the right, s kilometers an hour. Well, so in the time that it's traveled, in a quarter of an hour, that would just be s on 4. Okay, so straight away we can have an equation out of this, simply because we've got a Pythagorean triangle, so a right angle triangle. So we can just write it down. So we get x minus 3 squared plus s on 4 squared equals 10 squared. Okay. So that's the first bit of information there. The second one is, so then 15 minutes later, they are 13 kilometers apart. Okay, so the new diagram, again, we're going to have this freighter down here. It's now traveled another 3 kilometers upwards because it's gone for another 15 minutes. So now this is going to be x minus 6. And this distance here is going to be, well, before it was s on 4, if we add another s on 4, we end up with s on 2, right? So we'll just leave the rest, leave s on 2, and that's our cruiser there. And so that distance now is 13 kilometers. Okay, so we can immediately write down the equation again. So x minus 6 squared plus s on 2 squared equals 13 squared. Okay. So at this stage, hopefully you're thinking, well, we might try to expand, and we will indeed do just that. So I'm going to go ahead and expand this top one. So I end up with x minus 3 squared. I won't expand the x minus 3 for the minute. I'll explain why in a second. S squared on 16 equals 100. And so therefore s squared equals 1600 minus 16x minus 3 squared. Okay. So then I'm going to go ahead and expand this bottom one. So I'm going to get x squared minus 12x plus 36 plus s squared on 4 equals 169. Well, I can immediately substitute this s squared into here. And so I end up with x squared minus 12x plus 36. Now, if I divide all of this by 4, I end up with plus 400 minus 4x minus 3 squared equals 169. We're now going to go ahead and expand this bit here. So we get x squared minus 12x plus 36 plus 400 minus 4x squared plus 24x minus 36 equals 169. Okay, so then if we put all of that together, we finish with negative 3x squared. The x's we get minus 12x plus 24x, so plus 12x. And the numbers alone, we get plus 36 minus 36, so 400 take away 169, so plus 231. Okay, so that equals 0. If we rearrange, we get 3x squared minus 12x minus 231 equals 0. So straight away we can simplify because 231 is divisible by 3. Okay, to check that, just add up 2 plus 3 plus 1, that's 6. So if 6 is divisible by 3, so is 231. So we end up with x squared minus 4x. 231 divided by 3 is minus 77 equals 0. And actually that factorizes really nicely. We end up with x minus 11, x plus 7 equals 0. So therefore x equals negative 7 or 11. Well, for obvious reasons, x can't equal negative 7, so the distance can't be negative. So not feasible. And so if we just go back now to the question, see what it was asking. Well, it's asking us how far apart are the vessels when the cruiser is due east of the freighter. So we haven't quite gotten there yet. Okay, so all we've found so far is the x. We also need this speed s if we're going to work out this bit here. Okay, so to work out s is not so bad. We just use this equation, so this one over here. And so let me write it down again, down here. So we end up with we end up with s squared equals 1600, take away 16x minus 3 squared. I think that's right. Yep. So we put in our correct answer, which is 11 for x. So we end up with s squared equals 1600 minus 11 minus 3 squared equals 1600 minus 16 times 8 squared equals 1600 minus, so this is 16 times 64. So that one you can pretty much just do on a calculator. So 16 times 64, we will end up with 1024, I think. So 1600 minus 1024. So S squared is equal to 576. Okay, so 576, the square root of that is in fact 24. So S squared equals, so S equals 24. Again, this step, the square root, you can just do on a calculator. So we have S equals to 24. So that's the speed at which this cruiser is going, right? This cruiser here. So when the cruiser is due east of the freighter, that means the freighter has travelled a distance of X kilometers. So it's travelled a distance of 11 kilometers, as we found here. So let me draw the diagram again down here. Alright, so the cruiser has moved up to here, and that's 11 kilometers. Now, given that it's traveling at 12 kilometers per hour, it would have taken it, so T is equal to 11 on 12. So after 11 on 12 hours, how far away is the cruiser? Well, we know that the cruiser's speed, as we just found, is 24 kilometers an hour. So therefore, the cruiser is 24 times 11 on 12, remembering that distance equals speed times time. The cruiser is 24 times 11 on 12 equals 22 kilometers away. Again, we go back to the question to make sure that's exactly what it's asking. So how far apart are the vessels? Well, we can rephrase it if we like, but I think that's fine. So the cruiser is 22 kilometers away from the freighter. That's it.